All right. Rational functions and zeros. We kind of talked a little bit about this. Again, a lot of this you already know. This lesson you kind of know if you combine today's warm-up, if you will, with what you already know about rational functions, okay? So a rational function is a function that you have two polynomials, again, right? Polynomial over polynomial. This is nothing new. You already know about the horizontal asymptotes because we taught you about that. Well, your Algebra 2 taught you about that. I just reminded you about the horizontal asymptote. The top degree is less than the bottom degree, so the x squared will not divide into x. That's the way I do it. It will not divide into it, so it's at 0. But if you want to do Bobo or whatever you got to do to realize that the bottom one's bigger than the top one, it's at 0. So we have a horizontal at 0. That has nothing to do with today's lesson because we did that on Monday, right? We've explored polynomials previously in 1.5, hence 1.5, right? And we can utilize some of those concepts to help us understand rational functions like f of x. So again, we know f of x is g of x over h of x. We don't know that, but it's a polynomial over a polynomial. It's a rational function where g and h have no factors in common. They have no factors in common. We're going to have some that have it in common. We'll talk about that later, right? We know that f of x has zeros when the top is 0. When the top 0, that's a 0, or it's a root, or it's a x-intercept, right? That's when the top is 0. And when the bottom's 0, we know that's bad, right? That gives me undefined. We learned already from Algebra 2 that gives me vertical asymptotes. Okay, so vertical asymptotes for the bottom, the top are x-intercepts or zeros. And what happens if there's common factors? That's a whole, and we'll talk about that at some other time. Yep. That's a vertical asymptote, provided there's no common factor. Y'all okay? Good? All right, today's lesson. Again, some of that's future. When solving for rational inequalities, now this is new because you guys did not do this in Algebra 2. When rational inequalities, we need to identify both the zeros. Can I just go ahead and say the zeros on top and the zeros on bottom? So we need to identify the zeros and the undefined values. Okay, we got to identify both of those. So here's how you're going to solve inequalities. This is a step-by-step to tell you to do it in 7 steps, but don't make it near that hard because it's not, right? Make sure the inequality has 0 on the other side. That's a big key. When it's not equal to 0, we know it has to be equal to 0. So sometimes you got to move things to the other side. Sometimes. Always remember that. If it's not linear, I don't care what the function is. If it's not linear, you've got to set it equal to 0. Only way to solve them. Okay? You'll set g of x equal to 0 and h of x equal to 0. Or you're going to set the numerator equal to 0 and the denominator equal to 0. Okay with that? And then those are the values that you're going to have for your sign chart, like you did for several of those, the sign chart. Okay? Those are the values you're going to use for the sign chart. Of course, make sure to factor it because we want to make sure we find all the zeros. We're going to create the sign chart from step 3. Okay? It doesn't have to be equidistant. You can put 1 here and 2 here and 8 here. Doesn't matter, right? Be careful to mark values where it's equal to 0. We never include those. So h of 0 is the bottom, right? So they kind of telling you, hey, put a little star, put a little something right there. You never want to include those in the denominator. They'll never have a bracket, no matter if it's equal to, less than, whatever it might be, right? Because if you hit a bracket, that says it's okay to be that number, and it can't be, because that gives me 0 on the bottom. Okay, so do your little something to keep it in your head that, ooh, that's the h, that's the bottom, that's bad. Test values on each interval, just like you did for 1.5, right? And see if they're positive or negative, okay? And then interpret the sign chart to answer the given inequality from the problem. So again, it sounds like it's a whole lot, but it's a lot of stuff you already know. Be sure to write your answer in interval notation and think about the endpoints. Be careful about the endpoints, okay? So here's example number 1. Example number 1, right? Draw. Let's do brown. Oh, that's so nice of them. Oh, they're so nice because it's already factored. So I don't have to do a whole lot of mental math at all. I just got to make my little number line. I don't even put arrows on it. And my smallest value is -6. Wait, that's a positive. No, I know, but it takes a negative for it to be 0. The next one's a +2 and a +3. And again, they do not have to be, what do you call it? I don't want to say equidistant, but because they kind of are equidistant, but they don't have to be, yeah, proportional. That's a good word. Thank you. These math words confuse me sometimes. Good. So I've got a test, and now I like to put what? Star or something right there and a star right here because it will not include those values. Right? I like to do something, maybe put a circle, something to let that number stand out of my head that will not have a bracket because this has an equals to, right? So it could have some brackets. Well, it will not have a bracket here. It will not have a bracket here. So whatever you got to do to help you remind you, oh yeah, I don't need to put a bracket there. Okay? So we'll test something smaller than -6, -287. -287 makes that a negative. -287 makes that a negative, and -287 makes that a negative. So I have a negative and a negative and a negative. That's 3 negatives. 3 negatives makes it a negative. Y'all, I do that pretty quick in my head, but some of you guys need to do like negative, 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 whatever you got to do. Okay? If I start putting too many negatives, I start getting confused. And I just count how many negatives I have at the end. Okay? I just count how many I have. If I have an even number, it's positive. If I have an odd number, it's negative. Okay? Between -6 and 2, that's 0. Zero's in there. So 0 makes that a negative. 0 makes that a positive. 0 makes that a negative. That's a negative, that's a positive, that's a negative. Negative, negative, positive, 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 positive. And that's why they call it a sign chart. Those of you going to take calculus, you got to get used to sign charts. Okay? And then I got to go from 2 to 3. 2.5. Okay. 2.5, that makes that positive. 2.5, that's positive. 2.5, that's negative. Positive, negative, know what I say? Positive, positive, negative, negative. I do that right, I'm good. And now I got to go to the right of 3, 2,862. Positive, 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 positive. And then I want what? Positive, greater than or equal to 0. Negative, negative, negative. So it starts being positive at -6. It's equal to at -6, but I can't be equal to -6 because -6 gives me 0 in the denominator. So I've got to go from -6, and then I'm going to go to 2, and 2 has a bracket because 2 makes it equal. And then I'm going to put a union because you guys are freaking brilliant, and y'all like to put unions because your Algebra 2 teachers did a phenomenal job. And then I'm going to go, that's negative, so I'm back at positive. And so I'm going to go positive from 3 to infinity, and infinity always has a parenthesis, and then this 3 should have a bracket, except 3 gives me a 0 on the bottom, so that's bad, so it has to be a parenthesis. Because again, you guys learn that's an asymptote, so I'm getting really, really close to 3, but I don't ever touch 3. Yes?
How will doing this work with like imaginary?
That we don't care about imaginaries. Imaginaries don't cross 0, so they just stay above, right? They just put little crazy things in them, but we don't care. Y'all okay? Good? Great, good question. Okay, beautiful. Number 2. Oh, cuss! It's not factored. Told you, get good at factoring. They're going to ask you just enough factoring. Luckily, they're nice. The first one's really nice. X plus 2, X minus 2. And guys, y'all understand, I hope it doesn't matter if you do minus or plus first. Either way, you just got to get them both. Please factor, please factor, please factor, please factor, please factor. It will. They will. Well, -5, -5. So y'all can do that, -5, -5, or you can put X minus 5 squared. Again, it doesn't matter. It might be easier. I don't know. It might be better for some of you cats to do X minus 5, X minus 5. whatever you got to do. Some of you guys are probably good enough to realize that if I'm going to square it, it doesn't matter what the heck I put in there. That's going to be a positive. So I really don't need to plug and chug down here because it's going to be a positive. If you have it x minus 5, you might have to plug and chug. Just think about all that stuff, right? So number line, I need a -2. I need a +2, and I need a +5, and I'm going to put, and I'm going to put a circle or something around that 5. That might be the best thing because last time I marked it out and I really couldn't tell what it was. So maybe a circle or something. Plug and chug. Plug and chug. -476. Negative. That's always going to be positive. So negative, positive. 0, positive, negative, positive. 4, positive. My guess is 6, positive, because that's a bounce of some sort, except it's not really even a bounce because it's in the denominator. But all this stuff should somewhat help you with the graph. So I want it less than 0. That's nice because less than 0 only goes from -2 to 2. -2, 2, and these are parentheses because it's not equal to, and so I really didn't care about that, right? And that might help you guys too, right? You can almost put circles there. You can almost put circles there because you knew already it was less than it can't ever be equal to. Okay? All right, what else I got on these connotes? Oh, solve. So example 3, example 4, example 5, example 6. Do example 3 real quick. I don't need to be up here. I don't think it. I probably should have given you something besides 3. That's pretty easy. Today, you're number 28. You already done? Go! 4. Oh, what do you get?
I got open bracket,
Okay.
comma, infinity.
Open bracket 3 to infinity, and of course infinity has to be or parentheses, right? Okay, everybody good? Is there both the parentheses? Is that what you said?
Yeah, they're both those third row.
You said bracket.
Oh, sorry. I meant open. I thought it was like open versus closed.
Oh, I got you. Oh, so open parenthesis, not a bracket. Because open just means the left one. Closed one is the right one. It's okay. Any one of those look real difficult? Y'all ready? Homework? Let's look at the graph. I want to look at the graph, okay? Because the graph's a little bit different looking. Okay. So of all these, I think the hardest one might be number 5, just because we have 3 more. I mean, you got a couple extra zeros, but I want to look at the graph. I think you guys get the idea of this. All right, the graph of the rational function is shown. Use the graph to solve the following inequalities. Notice this time they just want to know when f of x is less than or equal to 0. So I'm going to look at this graph. Less than or equal to 0. Above, below. From -3 to -1. -3 to -1. It never touches. On a test, you might want to erase that because I couldn't tell for sure if that was a bracket or parenthesis. Y'all okay? If I can't tell, I have to assume wrong. I have to assume wrong. So that has to be a parenthesis, and -1 can be a bracket because it touches there. And it's okay to be 0 according to that equals. Oh, I'm not done. No, I'm also below this graph from 2 to 3. 3 also is a parenthesis. 2 is a bracket. If you want to put a comma or you want to put union or whatever you want to put in between that. I want it when it's greater than 0. Greater than 0 from negative infinity to -3. Both are parentheses because this is a greater than. I really don't have to worry about that part. Ooh, there's another little trick. There's -1 to 2. -1 to 2. Parentheses. And then I'm also from 3 to infinity. Yeah, it's not equal to. Not equals to, you'll never have a bracket anywhere. Not equals to, you'll never have a bracket anywhere. So that's kind of, again, a little checkpoint, right? This last one, when it's greater than 1, well, that's nice because 1 is my asymptote. So greater than 1, it's just everything above it, what happens to be that part of the graph and this part of the graph. So I can go, what, negative infinity to -3, and then from 3 to infinity. So this part right here is greater than 1. This part right here is the greater than 0. If it's greater than 0, it has to be greater than 1. I'm sorry, if it's greater than 1, it has to be greater than 0, right? So whatever this answer is has to be included over there, but then this also adds it because that's in between 0 and 1. Too fast